A very good morning to all. As discussed in the earlier regarding the wind and the hydro energy systems, up to what are the general factors affecting for the wind systems and then how the hydro energy systems are to work, are to discuss in the previous classes. Are to continue with today's, I go for what type of different type of factors affecting the wind. In these cases, there is a five categories of factors affecting the wind. One is the pressure gradient forces. Second one is the coriolis forces, and then frictional forces, and then atmospheric pressure, and centrifugal forces. So, what's the general meaning for the pressure gradient forces? Means normally the pressure gradient forces is the force that pushes the any type of air from area of high pressure to the low area of the low pressures, driving wind and influencing the weather patterns. For example, in this diagram I have shown, and to form as high pressures and then the net forces affecting from the middle of the pot and then low pressures. So the next one is the coriolis forces is nothing but as it is the coriolis force is an apparent forces that arises due to the Earth's rotations. So the affecting the directions of moving the objects, it deflects the coriolis forces will be occur as shown in figure. Next one is the frictional forces. Normally, any type of objects have moved from one places to other places, that frictional effects will be created. So, in this concept, the frictional forces, or it will be simply frictions, is in the forces that opposes the motion between the surface contacts. It always arises from the interactions of the microscopic irregularities of the surfaces and act in the directions opposite to the motions or intend the motions. Next case is the atmospheric pressures is based upon the air pressures or otherwise it will be known as a barometric pressures. To normally have to get it from the hill stations and the normal what do you call um, atmospheric surfaces. So in these cases, if the force is exerted by the weight of the air above the given point of the air, it is essentially the pressures exerted by the atmospheric on the everything within it. These pressures varies from normally any type of altitude of the weathers in the height of the hills and then at the lower part of the ground floors. Normally the atmospheric pressure at the level of 1013.25 millibars or otherwise 1013.25 hectopascals levels. So now all of them you have to go for the upper hill stations. The pressure value should be very less, and then the in the grounded positions level the pressure value should be the maximum. In between that value should be indicated. It will be known as the atmospheric pressures levels. Another one is the centrifugal forces. Is all of them the giant wheel or any type of um, uh, centrifugal forces playing games. So the centrifugal forces is always acting for the body moving in a curved path and it's directed toward the center of the rotations. The centrifugal forces formula, all of them that is the basically the value of forces is equal to mv squared by r. In these cases, v is the velocity and then r is the radius of the particular circle radius of the surfaces. So next, entering for the wind turbine components. So these are the factors, what the different type of factors affecting the windmill, and then what type of the places have to locate for the windmill. All those things I have to discuss in the previous cases. Now entering for the wind turbine components. So normally any type of wind turbine system, these are the main components should be occur. One is the foundations of the particular tower, basic foundations, and the nozzle hub, and then rotor, drive train gearbox for rotating the rotor surfaces, and then generators have to produce the electricity, and then electronic controllers and controller yaw for the controlling purpose of fan speeds for the high pressured air and then low pressured air, and then pitch and then braking and then cooling systems. These are the general components will be arise in the any type of wind turbine components. So in these cases, the basic components will be arise in the wind energy conversion systems. Normally, any type of aero turbine gearing coupling of electrical generator control means this is a black diagram for basic wind energy conversion system. First, I have to go for the aero turbine systems. Next, the aero turbine systems are to connect it to the gearing systems for the speed controls purpose. Next, I have to convert coupling with the electrical generators. Once the aero system turbines have to rotate, the gear systems according to the speed should be reduced, and then the torque have to maintaining for the constant value. Then only the coupling system speed should be maintaining, and then the electrical generator rotate at the constant speed. Then only have to rotate, give the electrical supply from the grid itself. So the aero turbine normally the wind directions or otherwise yaw control systems, it will be rotating the wind directions by way of clockwise or anti-clockwise positions. So suppose wind pressure should be the maximum, the aero turbines have to rotate in the maximum speed. That speed had to control by the gearing systems. As it is, the torque had to control. The constant speeds have to rotate from the mechanical interfaces in between the aero turbine as well as the coupling systems. So this is a basic component of the India electrical systems adopted in the 1988 itself. In nowadays, there is a number of changes will be occur. This is the internal view of any type of supporting structure of the gearing systems. Basically, any type of windmill having the wind turbine systems, and then the blades move in the clockwise or anti-clockwise. The blades have to place in that hub positions or spinner positions itself. The yaw motor or gear control systems have to reduce the speed by way of different type of pulse mechanical gearing systems. Then only the speed should be reduced or maintaining for the constant value. Then only the value have to convert it for the coupling with the generating, and then it will be produce the electricity. This is the internal part of any type of wind structures. So normally any type of typical grid connected, how the wind energy conversion systems are to connected in the typical grid means normally the grid is nothing but the number of electricity are to connected in the common point itself by the constant voltages and then the constant power factors. These are the electrical factors comes under. So in these cases, have to connect it for instead of one wind turbine, there is a number of wind turbine have to connect it in that particular grid through the common point systems. How it will be connected means this diagram is represented for the individual one single windmill. This will be the follow for the other windmill also. First case is the gearing box systems. Then only have to put it into the electrical generators. Again, that electrical generators have to rotate in the constant speed means it's not a problem, or otherwise any type of machines are to control by way of any variations. That will be converted into the electrical signal into the grid itself. The grid sides, the converter to the value of DC generator is again DC to AC conversions. The AC input is given to the step up transformer itself. Then only the step up transformer have to step up the voltage. For example, have to generate it for the 500 voltage in the DC voltages means in the case of step up transformer 500 is converted to the 10,000 kilovolts or something like this. Then only the final voltages are to connected directly to the grid itself. Any type of grid values is suddenly increasing or reducing means the feedback signal, the downward arrow mark are to indicate it from the load or utility grid to grid slides controller. That controller are to give the electrical informations, and only are to maintaining for the converter side supply for the input supply of the transformers. This is how the the typical grid connected with the WECS systems. Thank you.